So let's look at two very quick examples. So let's just say we have a sphere. And the sphere has a surface area of 20 meters squared. What is the radius? And what is diameter? Well, for a sphere, we already know that the surface area is 4 pi times the radius squared. So let's just isolate for r. So we're going to divide both sides by 4 pi. So what are we left with? We're left with r squared is equal to the surface area divided by 4 pi. Now we have a squared. How do we get rid of the squared? Well, each time you have, so let's just say you had x to the power of 3. Well, to simply just get rid of that, we'll take x cubed to the power of 1 over 3. Well, what does that give you? Well, this will just be x to the power of 3 over 3, which just isolates x by itself. And you can check this by taking 5. So 5 cubed to the power of 1/3 is really 5. So how can we check this? So first we'll take 5 cubed. So 5 cubed, 5 times 5 times 5 is 125. Now take that to the power of 1/3. So 125 to the power of 1 over 3. That's 5. So essentially exponents just work in the same way as fractions. So we have r squared. How do we just get r by itself? Well, we'll put it to the power of 1/2, or also known as the square root. Put it to the power of 1/2. The top exponents are just going to be 2 times 1 over 2, which is just 2 over 2, which is r to the power of 1, because 2 over 2 is just 1 over 1, which is just r. So, just going to do that to both sides. R is equal to the surface area over 4 pi. We'll just take both sides to the power of 1 over 2. That'll leave us with r is equal to the surface area over 4 pi 1 over 2. Now we can just plug everything in. So we're going to take 20, divide that by 4 times pi. We're just going to use 3.14 and then take the square root. And since we used units of meter squared, we know that that's just going to give us units of meters. Since it's meters squared to the power of 1 over 2, so meters squared, just like as if it was a number, it's just meters. So let's put that into our calculator. So 20 divided by 4 times 3.14 is 1 point, so 1.59 to the power of 1/2, so 1.59 to the power of 1 over 2, also known as the square root. That gives us 1.26 meters. So the radius is 1.26 meters. Now what about the diameter? Well, we know that diameter is just 2 times the radius. So it's 2 times 1.26, which which is equal to, plug that into the calculator, 2.52 meters. So now let's try to find the surface area of a cylinder. So we'll say it has a height of 5 meters and it has a radius of 2 meters. So what is the total surface area? Well, let's break it up into pieces like we did in the previous video. So we got the top, the bottom, and then the side. So the surface area of the top is essentially the area of the circle, which we know is pi r squared, which is pi times 2 squared, which is 4 pi, 4 times 3.14. Let's just punch that in our calculator. 4 times 3.14, 12.56. 12.56 meters squared. Because it's an area. Surface area of bottom, the exact same thing. Pi r squared. 12.56 meters squared. Now, surface area of the side. So we know that this is a height of 5 meters. And we also know from previous video that the length of this is just the circumference of the circle. And we know that circumference of the circle is 2 times pi times radius. And if you haven't watched the previous video, if you can just kind of imagine making an incision on here and unraveling it. So making an incision, unraveling it, essentially you get a line of length L, which is that right there. We know that from there to there, it's just a point from here all the way around, which is the circumference. So, surface area of the side, which is this rectangle right here, we know that it's length times width. Length is 2 times pi times the radius, and the width, where we labeled it here as height, is 5 meters. So it's going to be 2 times pi times 10, or 20 times pi, 20 times 3.14, and that should give us 62.8 meters squared. So now total surface area is just the sum of the individual surface area. So 12.56 meters squared for the top, plus 12.56 meters squared for the bottom, plus 62.8 meters squared for the side. That gives us a total of 12.56 plus 12.56 plus 62.8. So almost 88. We'll just round up to 88 meters squared. So we had something that kind of looks complex. Surface area of the cylinder. We broke it up into surface areas of individual faces that we already know the formulas to. And total surface area was just the sum of its individual parts.